Okay, in today's assignment we're going to do parametric modeling. Parts 1 through 3 of activity 8.1 in my PLTW involve creating a pear cam with parametric modeling so that you can change the nominal diameter and the pear cam will adjust itself and scale itself up and down using the parametric equations in your parametric model. So here's activity 8.1, parametric constraints. Go ahead and read through this information. A lot of it is repeated from the slide presentation we looked at earlier. So number 1 says study the image of the pear cam and table. You will use parameters presented as you complete the tasks that follow. Redraw this diagram in your notebook. Redraw this diagram in your notebook. Create this chart in your notebook, but leave space off to the right because you're going to add more to it. What you're going to do is you're going to go into Autodesk Inventor and you're going to go into the parameters screen. And as this opens up, I will show you what that's going to look like. You're going to click on this little function f of x button right up here in the above the ribbon, and that's going to open this screen. It's going to have model parameters and user parameters. You're going to use user parameters and you're going to click add numeric. And then you're going to fill it in according to this chart. These are the things that you're going to enter to the right of that chart you copied above. You need to copy this entire chart into your notebook and have all of this filled out before you begin using parametric modeling. If you are doing this at the same time, it's just going to slow you down, it's going to confuse you. If you do all of this beforehand using this diagram, this chart, and this information here, it will be extremely easy for you. I've already done this in my notebook, so as I go into enter the parametric modeling, it's going to be a little bit easier. So we're going to go through here real quick. Apologize, I should have had this open already. Next, finish. Okay, first time I've been on this machine, so it's making me do this. Parametric modeling is cool because with a little bit of forethought and planning, you can build a part that is completely scalable. You can, like sizes of a chute, you can just enter in one dimension and everything scales up and changes for it. Okay, so I've already created my chart in my notebook. I've created my diagram, so I know what all the D numbers mean. So I'm going to start a new part. I'm going to start a new. Before I start any sketches or anything, I'm going to go into my parameters and complete my parameters. Okay? So user parameters, I'm going to add numeric. For my chart, the first one I have is D. Now I'm going to go over here to comment first and say this is the nominal diameter. This is going to be the first dimension that's going to be used. Equation is just going to be 1 inch. It's going to be in inches, and I'm going to leave that there and say OK. Now I'm going to add another numeric. This one is going to be defined as D0. And this, according to my chart, is the radius of the max circle. And the equation is going to be it's 1/2 of D, so D divided by 2. I have my number lock on, excuse me, D divided by 2. There you go. Click up here and say add another numeric. If you just click add numeric, it doesn't remember some of the stuff you typed in, so click to the side first. D1, look at our chart, is the minimum radius. Radius minimum, and according to our chart, it's 1/4 of the nominal diameter, so that's going to be D divided by 4. Click off over here, add another numeric. D2. D2 is the offset of the minimum. So that formula is 1/2 of the nominal diameter, so that's again d divided by 2. Add numeric, d3, that is the whole diameter. Now that's a fixed. So all I have to enter is a number value. I don't have to enter an equation or anything. It's going to be 3/16 of an inch, so I can say 3/16 and just leave it there, and that will be okay. So add numeric, again we have another fixed value. D4 is the thickness of the cam. And that's fixed at 3/16 again, so 3 divided by 16. Just leave it there. Add numeric. Now, when you create an extrusion, it has a taper angle. Our taper angle is going to be 0, but we have to define this. So, since we're using angular, we got to change our unit to angular, and it's going to be in degrees. Say OK, and it's 0. It's set and defined. We're going to type in here and say extrusion taper angle, and just leave that there, and then say done. So now when I create my drawing, I don't have to enter numeric. I can enter my D values for my drawing. So new 2D sketch, I'm just going to create it on this here. So I'm going to say okay, I'm going to create a circle at the bottom, and the diameter of this is going to say D. Enter. It's going to say, oh, it's 1 inch. Got it. Now I'm going to create my second circle up here. And this, the radius of this is 1/4, so the diameter is going to be 1/2. I don't know why they define radius when you need diameter. Diameter is of the minor is, see, if I enter D1, it's going to give me the radius, which is too small. So I need to cancel. I hate when PLTW does this. So we're going to say radius is 1/2, so we're just going to say D0. There we go. Now we're going to do dimension. We're going to define the offset from here to here. Cancel. Dimension from here to here is the offset. The offset is D2, so we're going to say D2. It's going to move it. It's going to do the math for us automatically. Now we're going to draw our two lines and tangent them from here to here, and then okay, another line from here to here. Okay, let's look at our tangent tool. We're going to tangent this line to this circle, this line to the circle, this line to this circle, this line to this circle. Let's say finish sketch. Now we're going to extrude it. Extrude this whole thing, and we're going to extrude it. The extrusion distance, the thickness of cam is D4. And it's going to automatically do that. Now we're going to create our hole in the cam, so we're going to do start a new sketch. Right here, we're going to put a point right here. Say finish sketch. Now we're going to do a hole right here, and the hole width is defined, or the hole diameter is defined as D3. So we're just going to delete all this and just type in D3. Okay, it's going to do that automatically, and there we go. So there's our cam. So now you can see that if we come in here and say, okay, well, first we're going to change it to ABS plastic. And you can make it a different color if you'd like. Make it smooth yellow here. Okay, so now we can go into File, iProperties, Physical, Update, and be sure to record this information in your assignment. The area, or sorry, excuse me, the mass in pounds and the volume. I'll close that. Now I'm going to show you this. Let's say I want to go to a 3-inch nominal diameter. So I go to my very first user parameter here, and it says 1.0. I want to say 3.0. Done. And as you can see, it changes the scale of the cam while keeping the same frame, the same scale. It changes the size by keeping the same scale. I can go in here and say, okay, now I want 2-inch nominal diameter because I need a 2-inch cam. Done. So there you go. That's how parametric modeling works. Complete this with your partner. Post a screenshot of your user parameters right here, this area down here. Very good. And a screenshot of this.